Hey everyone, you're watching Circuit TV. Welcome to my channel. Recently my keyboard died, so I started to Google things like new keyboard, and since my desk is kind of small, I was looking for a 60% keyboard. Then I thought, why can't I build my own keyboard using the parts from my old keyboard? As you can see, I have harvested all the switches, its housing and keycap. And honestly, I can't find a new housing for this kind of keyboard rather than 3D printing it. And I will be making a 3D printed keyboard, but not now. In today's video, I'm going to show you how you can build your own mechanical keyboard. So let's get started. So as I said, my keyboard died and I'm harvesting its housing, its keys and keycaps. So I'm making a 60% keyboard, which means these stuff won't be included. Only this much layout is being used. So first step will be adding the switches onto its housing. And I have harvested the stabilizers from these switches because I'm designing a case for this, so it will be quite easier to harvest these on the same thing. I removed the PCB from it so that I can remove the switches and what we say, it was burnt up, so I'm just using this. I will be, once I designed and printed the case for it, I'll be changing the switch from blue to, I guess, red, because red ones are silent and I do some gaming in night, so that will be helpful for my surroundings. Just carefully place these switches. So this layout will be 60% ISO, and that's why the enter is kind of offset. Otherwise it will be like one more switch over here, and this switch will be transferred over here, and the enter switch will be a little bit bigger. So, and I guess that one also needs stabilizers. I'll be designing a keyboard that is not ISO. So why I'm harvesting these? Because I don't want to waste plastic, and anyways it was just damaged, so I can reuse these switches and the case. The only thing that was destroyed is the PCB. Actually it is also reusable, but I just destroyed its traces for the microcontroller, so that's why I have to remove that. Otherwise it works perfectly fine. Just sorry for the notification noise. I record from my mobile phone, so, and you can see that these are pre-tinned because of solder from PCB got tinned. This is how they sound. Hope it's getting recorded. Just making, I'm facing all the optical side which reflects the RGB away from me, although this keyboard does not have any RGB on it. These are MX style switches, so I will be buying MX style switches and creating MX hot swappable keyboard case. For the microcontroller, I am using RP2040, is it 2040 from Liveshare. Of course it's a clone from them. Something just went wrong. Yeah, it is in 2 pieces, so In the next video, I'll be showing how you can design a case for hand-wired keyboards, and I'll be designing a 60% keyboard. So I'll be using 61 switches in this keyboard. This will be escape from 1 all the way to backspace. The other layout will be standard except for these functions button. I will use these arrow keys over to these keys, and this one will be the function key. And let's add diodes to its backside. You can just lay it down on here. Let me just grab the diodes first. So these are the diodes that I'm going to use. These are 1N4148. It comes in a pack of 100. I'll need 60 of those. So we have to mount this like this, and the diode orientation will be column to row like this. Just make sure to get this black line away from the switch. That black line indicates how the current flows in the circuit, and for my sake of simplicity, I just turn these around like a circle at this point, like this, and push it over here. Repeat the same steps for every other diode. So I'll be back after I done the thing, the looping and placing the diodes thing. It's kind of hard to do on camera, so I have to jump cut it. So I have decided to change the orientation of the diodes. I will be placing them over this pad and like this. Just shape your diodes something like this, and they will slide onto your switches like this, and by means of this you won't get any mess around here. So, and it will be a lot easier to solder them once they are ready. I mean, the wiring is ready if it's like this. Once you cut these, you will get some sort of jumpers for the spaces like these ones. So we cannot solder them together without its jumper cable. So just once you cut this out, you will get its part for the soldering. So to make that shape, you need some pointy tweezers like these. Grab your diode, carefully place it like this. Grab this and twist it around your pliers. I mean tweezers, these aren't pliers. And just carefully. I'm not able to do this on camera. So if you need a little bit of room, just push your tweezer through it and carefully just do like this. Once you're happy with it, just place it like this, and then bend it out so that it will get its shape, and just a little bit more bending will help, and that's how you make the diode to work on. So let me just fast forward it and show you the soldering step. So this is how the diode orientation should look like after it's been done in its matrix shape. So once we solder all the rows together, then we will route the cables for the columns. In this keyboard there will be 5 rows and 14 columns. So I'm not going to use these and these remaining ones, because as I told you, I'm making a 60% keyboard because that will be suitable for my desk, so that I can use this much and the rest of it for the mouse movement. And I was talking about once you break all these, Then we can stack them if needed, some sort of long distance keys. Then we can just use these to solder them. I will be using this hand skid soldering iron, which is kind of dirty because I have been using it for like 2 to 3 years, I guess. We'll be using 4060 lead soldering wire. So let me show you. I will show you how you want to solder it, and then jump cut it to match it with the rest of the video, because I don't want the video to get very long. So I just break it off, that soldering wire. Once your soldering iron is turned on, increase its temperature to like 250 to 60 degrees. I'm using 260. I will be showing you on this first switch how to solder on it. Once the wire is started to melt, we can start to solder. It's melting. Just make sure to keep the soldering iron for shortest period of time, because you don't want to melt these plastic part. It's kind of hard to get it. Yep. Once it's done, just make sure it does not move, and then grab just solder it on this point. And then with the help of tweezers, and it's done. Now repeat it as many times as you need it. For the switch matrix, I have to do it for like 61 times on each and every diode. So let me just jump cut it and show you how to control the. So now all the diodes are soldered. We have to take some cables and do the columns. I'm not going to show this on the video because I'm not using tripod at this moment. So I will be using red and black for the rows, which should connect at these 5 points, and blue, yellow and green wires for the rows, alternatingly, like blue, yellow, green, blue, yellow, green. So I will just jump cut it and show you how the matrix looks like. So the wiring of the matrix is done, and I have connected it to the microcontroller, that is RP2040. It's RP2040 0 from Waveshare. So I have used insulated copper wires to connect each and every row and column to the microcontroller. So once everything is assembled in its housing, I just shoved a USB-C cable inside this by cutting some amount of the plastic that was in the way, and that's how you make your keyboard. In the next video, I'll be teaching you how you flash firmware onto the RP2040. That's the microcontroller I'm using, and designing a 3D printing case, or 3D model, you can say. And that's it. Hope you enjoyed the video. Thanks for watching.